background paper looks like this. Okay, I mean it may not have the same cover page lah, but the inside must be like that one. Okay, I know yesterday got some absentees, so forgive me. Right? May I know who doesn't have? Okay, I actually don't need it today. I just wanted to check that everyone has. So Rose, you can take back yours. Okay, that you're very kind about. Okay, so please make sure that everyone has it. So if you have already got it, just leave it inside your bag. Okay, because for the next lesson, I will definitely need it. Okay, those who don't have it, please go and get it. And then also, okay, bring a long ruler as well, because you will need long ruler when it comes to drawing of your graphs. Okay. Today we will finish up our chapter 7. Okay. Before we start on chapter 7, I want to also inform you that on Thursday for our home-based learning, okay, we will be starting on chapter 6, okay, that is on your graphs. So after completion of chapter 6, that means our volume A of our textbook will be completed already, then we can move on to our volume B. Okay, so that's why there's a change in sequence. Okay, now we will complete our chapter 7 first. Okay. Consequences. Okay, so today I want us to take a look at exercise 7A, question 11. This is in your textbook, page 187. Just to get ourselves warmed up, although the weather already very warm, not sure whether you feel the heat at all. Okay, look at this sequence that we have. We have negative 3, negative 10, negative 17, negative 24, and negative 31. Okay, in part I, we want to write down the next two terms of the sequence. So I'll call out a name, so get ready to stand up. Okay, Lucas Hay. What's Lucas Hay? Stand up. You don't want to no. Lucas is confused. Lucas, it's your turn to answer the question then, since your last is to stand. Maybe he really wants to barely answer the question now. Okay, can you tell us what is the number pattern going on in this method here? Plus 7. You sure it's plus 7? Negative 3 plus 7, does it give us negative 10? Plus negative 7. So instead of telling me plus negative 7, how do we simplify that? Minus 7, right? Okay, so it will just be a minus 7 from one term to the other. So I don't have enough space here. Okay, so the pattern going on is a negative 7. Okay, so then Lucas, can you tell me what is the next two? What are the next two terms? Negative 31, what would it be next? Negative 38, followed by? You got a calculator, right? So what's the next term? negative 45. Okay, so the next two terms are negative 38 and negative 45. Okay, in case you have forgotten my rules, right? When I call a name, that person whose name is called out need to stand. Okay, then after that the left, right, front, back also need to stand. Okay, then the last person standing will answer the question. Okay, so this will give us a 5. Okay, part 2. Question wants us to find in terms of n a formula for the nth term of the sequence. Okay, so what we did yesterday was that I will list out, okay, what are the terms that we have. Since there are 5 terms, I will list out, okay, T1 to T5 to represent first term to fifth term. And the terms are negative 3, negative 10, negative 17, negative 24, and negative 31. Okay? Then because the pattern that we observe is that from negative 3, I will minus 7 to get negative 10. So negative 10 is equals to negative 3 minus 7. Okay? Then after that, for negative 17, we take the previous one minus another 7, which is 2 times of that. Okay, so we put bracket 2. Okay, because we minus 7 twice from the start. And then for negative 24, we are minusing 3 times of 7. So I will put bracket 3. And finally, when it comes to the fifth term, I will minus 7 4 times. Okay, so I present my answers in this manner, okay, to help us to find out the formula itself. Okay, the formula is for the general term, which we call Tn. And we notice the pattern going on, okay, in this structure is that we always have minus 3 and we always have that minus 7. It is only the things inside the brackets that keep changing, and we observe that, okay, the number inside the bracket, okay, in this case it is a 2, but it is for term number 3. When it is term number 4, we minus 1, we get the value 3 over here. When it is term number 5, we minus 1, we get a 4 over here. So in this case, if it is the letter n or the variable n, we will take n minus away 1 to place inside my brackets. Okay, so therefore, my general term in this case, just shifting it up here, okay, would actually need to be expanded to simplify. So minus 3 minus 7n, and taking note that this is a minus 7, so expand inside, okay, I will get a plus 7. Okay, so I can simplify negative 3 plus 7, that will give us a 4 minus 7n. Okay, so in your WE2, I think there's still a number of you who do calculation mistakes to think that negative 3 plus 7 is equals to negative 10. That's not true, so please use your calculator. Okay, questions? Right, so that is to reinforce what we learned yesterday, in case you have already forgotten. Okay, now let's take a look at part B. We are given another sequence, negative 93, negative 100, negative 107, negative 114. Okay, so part I asks for the same thing. You can ignore the instruction about comparing this sequence with the sequence in part A. So if you are reading the question in your textbook, ignore that. Okay, I want to do an amendment to that question. Okay, write down in terms of n the formula for the nth term. Okay, so the same thing. So I want you to take about 2 minutes, okay, do the same thing, figure out what is the nth term, okay, set my timer to 2 minutes. Can you please do that inside your notebook right now, okay? you're ready, keep your columns over here. I want 3 people to come out to present. Okay, 1 from each group. Okay, anybody will do, just 1 person will do. Okay, so how about I present? Hello, 5 points each. You're done. I don't call names, yourself. Up already. I have rows from that group over there. I have someone from the center group. There's someone from the group over here. No need to feel paiseh. I'm not asking for the correct answer. Just give me 1 answer on the whiteboard. Thank you, Siru. Anybody else? Okay, Evan stood up first. Sorry. Evan or see, your scissors paper stone. Take a marker. Write down for me the working, please. Pause. Okay, I want you to look at their answer. We bring the negative 86 over to the right, that gives us plus 86. Okay, and upon calculation, we get negative 182. negative 7n equals to negative 182, and therefore n is equals to negative 182 divided by negative 7. And we find that the value of n is equals to 26. Okay? So because the value of n is equals to 26, it is a whole number, okay? It can be a term itself because this is term number 1, term number 2, term number 3, term number 4. We realize that all the terms can only be counted in whole numbers. I cannot have term number 2 and a half. I cannot have term number 3 and 3/4. Okay? So what I can have only for term numbers is that it is a whole number. So because it is a whole number, we state by explaining that since n is a whole number, okay, therefore negative 268 is a term in the sequence. Okay, so that is how we go about explaining. Please do not, okay, actually go about finding the term itself because that is not efficient. Okay, if I give you 1,256,000, okay, that will take you forever. Alright? Okay, questions? Right, I want us to extend this question, so I'm going to throw in another part 3. Okay, I want to ask, is negative 725 a term in the sequence? Okay, explain your answer also. Okay, so by the same logic, okay, that we did in part 2, alright, we will take negative 86 minus 7n, equate it to negative 725. Okay, and then we proceed to solve to find out the value of n. Okay, and in this case, what is negative 725 plus 86? That is negative 635. Okay, and n is equals to negative 639 over negative 7. And we get 91. And 2 over 7. Okay, so in this particular case, we see that n is actually a mixed number. So because it is a mixed number, it is not possible to be a term itself. Okay, it cannot be a term number itself. Therefore, we conclude by saying that since n is not a whole number, okay, therefore, negative 725 not a term in the sequence. Okay, I'm showing you 2 ways of doing your presentation of your answer. Okay, depending on the question, sometimes it can be a term in the sequence, sometimes it cannot be a term in the sequence. Okay. Question 6. Okay. It's given that the nth term of a sequence is given by 12 minus 5n. So they did not give you the pattern at all. They didn't give you the sequence. Okay, they only gave you the formula itself, which is 12 minus 5n. And this formula helps us to find out every single term, okay, that can be found inside the sequence. Okay, so we want to write down the first three terms. So the first term itself, okay, which we call T1, will be such that n is equals to 1. So we replace the n by 1, and then we can use our calculator to calculate that, and we see that the first term is 7. Okay, then naturally to find the second and the third term, okay, replace the n by 2. And in this case, we will get the value of 2. And then in my third term, replace the n by 3. And I will find that I get negative 3 for my third term. Okay? So that is your first three terms. Any questions so far? Alright, then let's take a look at part B of that same question. Okay. It says that they gave you this number sequence 5, 12, 19, 26. Okay, we want to find the expression of the nth term. So it is the same thing, okay, same process. List out, okay, T1, T2, T3, and then T4. Okay, so 1 to 4, those are the terms. And then we figure out what is the pattern going on. So 5 to 12, okay, we find that there's a pattern of what? Okay, let's call another name. Hansha. I think you're really not getting the name. I really say myself, call a name that person is supposed to stand. Likewise, the left, right, front, back. Okay, hello, are you awake? Elise, you are the one that's not standing. You're supposed to answer this question. You don't like to play games, is it? You don't get game rules. Like, is the heat getting into your brain? Is it? You all seem very deep today, you know. Like you are robots. Okay? Now Elise, what is the pattern going on? From 5 to 12, what do you do? What do you see? 5? Huh? Plus 7, right? Okay, so the pattern going on is a plus 7. Okay? So therefore, our 12 itself is 5 plus 7. 19 is 5 plus 7 times 2. And then fourth term is 5 plus 7 times 3. Therefore, our formula, okay, it will actually be 5 plus 1. Let's try again. Sing room. Elena, you are the one. I have to know your classmates around you. Okay? Elena, can you tell me what is the formula? Very good. Okay, 5 plus 7, bracket n minus 1, excellent. Okay, and then we have to extend it and simplify. Okay, and then we will get 5 plus 7n minus 7. So 5 minus 7 is a negative 2. So we can write negative 2 plus 7n. Alternatively, you can write it as 7n minus 2. They mean the same thing. Okay, they are equivalent, they are equal to each other. So either one of these answers are perfectly fine. Okay? Alright, then let's take a look at part 2. Okay, part 2 wants us to find the 15th term. So T15 will be be when n is 15. So we place in the formula n to be equals to 15, and what we will get is 103. Okay, so for part 1 and part 2, we have done something similar already. My intention of going through this question is to make sure that we understand what does part 3 actually mean. Okay, so part 3 asks us to find the value of k if the k term is 222. So instead of calling it nth term, they now call it k term. Okay, so they want you to find out what is this value of k. So what the question is saying is that tk, that value that comes out of it is 222. Okay, so instead of using n, it is being used as k. So therefore, using my formula, I'll have 7k minus 2 equals to 222. Okay, so we form an equation like this to help us to solve to find out what is k value. So 7k equals to 222 plus 2. That will be 224. Then we divide by 7 and we will get 32. Okay, so k equals to 32. Alright, questions? Okay, so if no questions, let's move on to 7.2. Okay, 7.2 is slightly more fun because it is not really that much about your numbers. Sometimes you will get to draw patterns as well. Okay, so 7.2 is about number sequences and patterns that look slightly different. Okay, so looking at practice now for question 1 part I. Okay, this is in your textbook page 190. I'm not going to write the question on the whiteboard, so I want you to turn to your textbook page 190. Okay, the question gave you 4 figures, and then after that, draw the next 2 figures of the sequence. Okay, they want you to draw figure number 5 and figure number 6. Alright? There are only 2 figures over here, so okay, I want 2 people to come up. Fastest can hand first up. Okay, draw 1 figure 5, 1 figure 6. Are you all ready? Okay, so fastest finger first to earn points for your team. Okay, can you draw out figure 5 and figure 6? Right? Okay, whoever that's ready, can please come back, grab the marker and draw. Are you all okay? You are unenthusiastic, you know? Can someone come back and draw figure 5, figure 6? Thank you, Auntie. Anybody else draw figure 6 for me, please? See the pattern. Auntie draw on top of the word figure 5. Nobody's stopping you, nobody seems interested, yeah, you can earn double the points for your team there. The rest of you, I expect you to draw inside your notebook. Come on, this kind of things really need to tell you. Okay, thank you. Okay? This kind of thing you primary school also do already, so I really don't understand why you're waiting. Okay? So, you see for figure 5, okay, maybe it may not be clear, but there should be 6 dots over on the side here, and 7 dots. So it should be 7 dots and 6 dots. Okay, so please check your own work. Okay, make sure that they are aligned. Right? Because this whiteboard got a hole, this is not a dot. Okay, so 7 dots by 6 dots. Then after in your figure number 6, there should actually be 8 dots across, and then vertically we should have 7 dots. Okay, so please draw that out. You are expected to draw, okay, when you are given figures or other number patterns that involves figures. Okay, next we look at part 2, whereby there is a table. Okay, whatever that's convenient. Okay, you may want to just fill in the table inside your textbook, or you want to copy the same thing into your notebook also can. Okay, so in that table you have the figure number, okay, and then also number of dots. I'm just going to write in shorthand. So in your row number 5, okay, what do you think should it be, okay, to fill in for the number of dots? What will your answer actually be, Joel? I keep up with you, know. Joel, you're supposed to stand when I call your name. Joel, you should answer the question then, okay? Row number 5, what do I get? Number of dots. No, just follow the pattern, please. Follow the pattern. Okay. First figure, there are 2 plus 1 times 4 dots. So then on that second figure, we have 2 plus 2 times 4, right? Then third figure, we have 2 plus 3 times 4. Fourth figure, 2 plus 4 times 4. So okay, follow the same structure. Tell me what is it? Should be 2 plus. Okay, 2 plus 5 times 4, that will give us 22. Okay. Alright. Okay. Then after that, what about row number 6? Please don't make me give up. Carbon. Okay, let's see the last one. Alright. Let's see, okay, tell me what is the row number 6. Follow the pattern. Yeah. Sorry? No, tell me what is the structure. Same. 2 plus 6 times 4, and that is equals to 26. Okay? And finally, coming down to the nth one, okay, the general term, what do you think it is going to be? Okay? Kyra. Very slow motion, you're like sloths. Ziyi, can you tell me what's the answer? I think it will be Ziyi. Yes, Ziyi. Okay, follow the structure. It will be 2 plus 1. You see the number pattern going on here? You see 2 plus 6 times 4, that means 6. 2 plus 5 times 4, that means 5. 2 plus 4 times 4, that means 4. Do you see that the numbers here actually change? So that means should be 2 plus 1. Huh? Sorry? 7? This is n there. So that means should be, if down here 6, down here 6, down here 5, down here 5, down here n, then down here what's plus? Huh? Sorry? N, right? Okay, yes, n times 4. Okay, then after that we simplify this. This one of course cannot press calculator to get a number, right? So it will be 2 plus 4n. Okay, we don't leave it as n times 4. Alright? Okay, then part 3. Okay, of the question. Okay, part 3 asks to find the number of dots in the 2020th figure. That means following this, okay, we want to know 2020, what is the answer? But do I really need to follow the same structure again? I don't need, because I now have a formula already. Okay, so when your n is equals to 2020, I will have 2 plus 4 times 2020, okay, and that would actually give us the answer 8082. So this is the number of dots, okay, for the 2020th figure. Okay. Then in part 4, the question asks, will there be a figure in this sequence that has 80,000 dots? Explain your answer. So it's the same thing as what we did earlier just now, okay? To see whether there is a figure that has 80,000 dots, that means that we are looking at using this formula, 2 plus 4n equals to 80,000. And then we check to find out what is the value of n, and that will be 4n equals to 80,000 minus 2, so 79998, and n equals to 79998 divided by 4, and we get 19999.5. Okay, how many nines are there? 4 nines. Right? Yes. Okay, so because we get a 0.5, that is not a whole number. We explained that since n is not a whole number, okay, therefore there is no figure that has 80,000 dots. That has 80,000 dots. Okay. Okay, let's do another one, question 2. So in question 2, right, we want to write down the 8th line in the pattern. So this is considered the first line, okay, second line, and so on. Down here, dot, 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 we don't know how many lines are there until 110. Okay, I want to know what is the 8th line found inside the pattern itself. Okay, what do you think the 8th line will actually be after observing this pattern going on? Okay, so the 8th line is to be a number, something times something. Okay, so what do you think is going to be? Let's call another name. Xavier. Okay, Action is the last one. Action, can you tell me what is that line that we have? It will be easier to start on the right side. What should these numbers be first? After seeing the pattern. First line is 1 times 2. Second line is 2 times 3. 8th line is 1 times 1. No, not talking about 110. I'm talking about 8th line. The 8th one. We don't know what is the 8th one. This one I don't even know what is it. So what times what will be the 8th line? 9 times what? 9 Huh? I think something is not right over here. You either don't understand patterns. Huh? 8 times 9, right? Okay. Okay, so please observe the patterns. I think everything the heat is getting to us today, this morning. Okay, this is quite obvious, right? First line 1 times 2, second line 2 times 3, third line 3 times 4, fourth line 4 times 5. So each one must start with 8, right? Then times 9. Okay, then you press your calculator. In case you don't know your 8 times table or 9 times table, then it's 72. So the 8th line is 8. 72 equals 8 times 9. Full stop, that's all. Okay? So that's the 8th line. Okay? Then looking at part 2. Okay? Part 2 asks you to deduce the value of k. Okay, that means to find out what is the value of k in this case. Okay, so 110 equals to k times k plus 1. You can do a lot of try and error, but I think that try and error may not be that efficient. Okay, so what I would propose is that you can consider taking square root of 110, press it into your calculator, and then after that see what is the number that you get. In this case, you will get about 10.488. Okay. Now, why is it that I'm proposing to do square root? Okay. That's because, right? Notice what are we multiplying over here? We're multiplying two consecutive numbers. Okay. They are close to each other. I know that things like 4 will become 2 times 2. Okay. 9 will be 3 times 3. 10 will actually, sorry, not that. 16 equals to 4 times 4. Okay, so because of this similarity that I'm trying to draw over here, when I take square root, it will give me a hint, okay, to make things faster. Then I check that 10 times 11, okay, it does give us 110. Therefore, your k value must be equals to 10. Okay, so this will actually be faster for us to determine rather than to do all your try and error, okay, to see what times what will give us 110. Because the two numbers must be consecutive. Okay? Then in part 3, again the question is asking, will there be a line with 342 on the left hand side? Okay, explain your answer. Okay, forgot to give extra than 5 points. Alright, so we are looking at the left hand side, okay, of the equal sign. The question is asking whether 342 will ever appear. Okay, so also it is not feasible for us to do try and error. Okay, even if you do 342 equals to some number times another number, n times n plus 1. Okay, at this juncture now, we don't have that skill, okay, to actually solve this kind of equation. You can solve it when you go up to set 2, okay, or maybe sometimes set 3, depending on what it comes out to be. Okay, but at this juncture, we don't have that skill to solve, okay, such an equation. Right, so an easier way to get around it is to really try to find, okay, using this square root idea, we take square root of 342, see what is that number that we get, okay, using your calculator, we get about 18.493, okay, 18.493, and then we do a check, okay, if I take 18 times 19, what is it that I will get? I will get 342. Okay, so it is just a coincidence that I'm able to find this. Alright, and then we say that because we can get two numbers, okay, that are continuous, that are consecutive, and it results to be 342, follows this pattern that we have over here. That means that there will be a line with 342 on the left hand side. Okay, so since there are two consecutive integer integers that multiply to 342, there will be a line with 342 on the left hand side. Okay? Questions? Okay. I want you to go back home, do homework. Okay, and submit to me on Friday when we meet. Okay, 2 exercises, you can do it in continuous foolscap paper on the floor. So 7A, do question 459. And exercise 7B. Okay, do question 1, 2, 3. Okay, these 6 questions, it is really a test of whether you can observe patterns or not. Okay, maybe you don't like patterns because you don't like to fit into stereotypes, I'm not sure. But number patterns is something you need to be able to observe. It is a crucial skill in mathematics. Okay, so due on Friday. Don't have to do it on 2 separate pieces of foolscap. If there's space, you just do it on the same foolscap. Okay. Please don't do it in columns, and then please don't draw. Then make sure it's neat, okay? Okay. So on Thursday for home-based learning, make sure that you do the SLS lesson that will be on chapter 6. Okay, on Friday when we meet, please make sure you bring your graph paper as well as your long ruler. Okay, if you don't have it, go and buy it. Okay, we need it on Friday itself.